Hi everyone. We are ready to do some section 6.4, elimination with multiplication. This is going to sound a lot like section 6.3, where we had elimination. Now we just got to do a little bit of work to make those coefficients the same in front of either the x's or the y's. So first of all, everybody knows, right? A system of equations, two or more variables. The only way we can solve them is by graphing them, doing substitution, or doing elimination. So if we're going to eliminate with multiplication, it's the same as plain old elimination from section 6.3. However, you will not always have the same coefficient, so you're going to have to multiply every term in one equation so that you can make common coefficients. Remember opposite signs. We want one of those coefficients to be a positive, one to be a negative, so when you add straight up and down, you can cancel those guys right out. And of course, your answer is an ordered pair. If we graph these, it would be where those two lines intersected on a coordinate plane. So let's talk about some steps for elimination with multiplication. First of all, if things are out of order, not in standard form, make sure your variables, equal sign, and constant are all lined up. That is standard form, ax plus by equals c. So make it that way if it's not. Look at your coefficients of each of your variables. Decide what can easily match up. What do both of those coefficients go into? What could we multiply by to get there? You do need to multiply the entire equation. And watch out for those signs. Multiply by a negative if you need the opposite sign. Multiply, if you're multiplying it's already a negative, just watch those signs. You multiply the entire equation. I think of it like distributive property. Then once you get there, you've got the same coefficients for one of your variables, opposite signs. Add the equations straight up and down, and you'll eliminate one of the variables. That's the whole point for elimination. Go ahead and solve that so that you know what one of your variables is equal to, and then substitute to find the other variable. Because remember, your answer is an ordered pair. We need an x and a y. If for some crazy reason they give you s's and t's, you're just going to put those as an ordered pair. Always just go alphabetical. So let's try a problem or two. So it says directions say use elimination with multiplication to solve the system of equations. At some point, we're going to just say solve the system. Use whatever method makes more sense to you. When I look at these two equations, the coefficients of my x's are 3 and 5. The coefficients of my y's are 2 and 4. I don't even look at the constants. I don't care about that 6 and negative 4 quite yet. What would be easy to make the same number? Would it be easiest to make the 3 and 5? What do 3 and 5 both go into? 2 and 4, however, both go into 4, right? So that would be easier. We're going to have to multiply the bottom equation to make that 2y into a 4y. So I'm going to multiply this whole thing by 2. And then my y coefficients do have the same sign, so I want to make that a negative 2. Because when I multiply, I'll get a negative 4y. It'll cancel out with that top equation. So my first equation is going to stay exactly the same. No changes needed there. I only need to multiply one of the equations. It could be that I need to multiply 2. When I multiply the second equation by negative 2, remember distributive property. Think about multiplying everything. So negative 2 times 5x is negative 10x. Negative 2 times the 2y is negative 4y. And negative 2 times the negative 4, watch the signs on that, that would be a positive 8. The hardest part is done. Now we're going to just put a big old plus, add those guys together. 3x plus a negative 10x is going to give you a negative 7. The y's cancel out because 4y plus a negative 4y is no y's left. So we've just eliminated the y's by doing this. Bring your equal sign down, and 6 plus 8 is 14. Super simple one-step equation to do. So divide both sides by negative 7, and you end up with x is negative 2. But we're not done with this, right? The answer's an ordered pair, so I want to know what y equals. So go back to your original equations, pick the one you like better. Some people avoid the ones with negatives and whatever looks best to you. I'm going to go back to that top equation. 3x plus 4y equals 6. I know the value of x is negative 2, so I'm going to substitute that in there. So I'm going to have negative 6 plus 4y equals 6. Two-step equation, I'm going to add 6 to both sides. So 4y equals 12. Divide both sides by 4, and y equals 3. So my ordered pair answer for this will be negative 2 for x, 3 for y. Wasn't really that bad. We could have solved or eliminated the x's. We would just multiply both equations in order to make them the same coefficient. So I always try to find the easiest one where I only have to multiply one of the two equations. Let's try another example. Let's hop up. I'm going to skip number 2. Feel free to do that one. When I look at number 2 and I look at my coefficients, hopefully you can spot which one's easiest to eliminate. For the x's, I've got a positive 2 and a negative 1. And for the y's, I've got a 3y and a 2y. Well, I could get the y's to be the same number. They both multiply to become a 6 at some point. But what would be much easier would be the x's, because a positive 2 and a negative 1, I could make those both 2's. And then I notice I've got opposite signs already. Maybe we should do this one. So we're going to multiply this bottom equation by 2. And I'm not going to worry about the y's. I'm going to leave the y's. So I'm just going to get those coefficients. My top equation is not going to change. I'm just going to go ahead and rewrite that one. My bottom equation, however, is going to become, when I distribute, remember to distribute to all three parts, negative 2x plus 4y equals 5 times 2 is 10. And now I've got myself a problem where I can just put my adding sign here. What do you notice about your 2's? Hopefully you see that a 2x plus a negative 2x cancel out. 3y plus 4y is 7y. And bring your equal sign down. 4 plus 10 is 14. It just so happened we got 7's and 14's again. It won't happen every time, I promise. So when I finish solving that equation, I get y equals 2. So I'm going to figure out, because I'm not done, remember, I've got to find out what my x is this time. So I'm going to go to my top equation, 2x plus 3y equals 4. It doesn't matter which one you go back to solve. I know that y is 2. So I'm going to have 2x plus 3 times that 2 is 6 equals 4. Solve this guy by subtracting 6. So 2x equals negative 2. Divide both sides, and I'm going to get a negative 1 for my x. Write my answer as an ordered pair. My x value is negative 1. Y was 2. So negative 1, 2 is my answer on that one. Let's do one more just for good measure. Let's do one that we have to multiply both of the equations. So it's your option, whatever one you like better. When I look at my coefficients of my x's, I've got a 3 and a 2. 3 and 2 can both multiply into what number? What is a factor of both 3 and 2? I could do a 6 on both of those, right? Would I have to multiply one or both of my equations on that? Both of them? Do I have to worry about my signs on that one? I do, right? They're both positive, so one of them I'm going to have to multiply by a negative. When I look at my y's, I've got a 4 and a 3. What do 4 and 3 are both factors of what number? 12. But what do you notice about the y coefficients as far as the signs? The top equation has a plus 4y, the bottom equation has a minus 3y. So that means I don't have to worry about signs if I multiply to get the y's to be the same number. So I'm not going to worry about the 3's or the x's. I'm going to multiply this top equation. What do I need to multiply the top equation by in order to get that 4y to become a 12y? Multiply that by 3. The second equation, I want that 3y to become a 12y, so I'm going to multiply everything there by 4. And again, I don't have to worry about signs because the y's already have opposite signs. So both equations are going to change this time. I've got to distribute that 3 on the top equation and the 4 on the second equation. So for the top equation, 3 times 3x is 9x. 3 times 4x is a positive 12y. I meant a y. And 3 times negative 25, don't forget that one, is a negative 75. If there's anything that I see people make goofs on, they forget to multiply the constant or the number over there by itself. Don't forget that part. Second equation, I have to multiply everything by 4 in order to make my y's have like coefficients. So 4 times the 2x is 8x. 4 times the minus 3y would be a negative 12y. And 4 times 6 is 24. We've now got ourselves a nice setup where we can just put a big old plus sign in between them. So remember, we're adding 9x plus 8x is 17x. 12y plus a negative 12y. Hopefully you all spot that that one will cross itself out. And bring your equal sign down. A negative 75 plus 24. I'm going to say that's like a negative 51 maybe. Please double check my mental math. And then I got a one-step equation. Finish solving that. Divide both sides by 17. It looks ugly, but I'm pretty sure that comes out to a negative 3. We're not done. We want to make sure that we get the y as well. Which equation would you go back to solve for y? Does it matter, first of all? Doesn't matter which one you pick. I'm going to pick the second one this time because I haven't picked the second one and because the first one has a negative 25 in it. I don't want to do that. So I'm going to go back to a 2x minus 3y equals 6. I just found that x is negative 3. The tricky part about this is you better trust your own work, because if you found x wrong, then your y is going to be wrong. So you have to be very careful and vigilant as you do these. So 2 times negative 3 is negative 6 minus 3y equals 6, which means I've got a two-step equation. I'm going to start by adding 6 to both sides. So negative 3y equals 12, and of course divide by negative 3. So I'm going to say that y equals negative 4. My ordered pair for this then will be negative 3, negative 4. There's one more system on your note sheet. Feel free to go ahead and do that one. Do it as a trial, see how you're doing. But I've got 2 things to end the lesson. First of all, in the lesson summary, I want you to jot down what's one important thing to remember when you're solving a system of equations by elimination. What do you have to remember? So as we were doing, especially by multiplication, as we were just doing those 3 examples, what did you forget? What do you need to remember to look for? What do you need to remember to do? So one important thing to remember, if you got more than one, please put more than one, but one important thing to remember. If you remember everything, then what would be your advice to your neighbor? And I'm going to give you one practice problem to do. Make sure you've got this one all set. It says solve this system. You're going to have to solve it by multiplication, elimination with multiplication. So your first equation is 4x plus 3y equals 8. Second equation is 3x minus 5y equals a negative 23. There's some big numbers in there. Your answers will come out to whole numbers, no decimals or fractions. So this will work. So remember, you're going to be looking for what coefficient could you make for the x's or y's that you could easily do. You're going to have to multiply both equations on this problem. Have a great day. Go back and rewatch if you need to check anything, or if you didn't get everything filled in. Remember, you can always pause as you're watching. Have a great day. We'll see you tomorrow.